Good morning. My name is Michael Alexander, and today I'm going to walk you through a professional development on the theory of the backward design. The backward design is a theory um, that educators can use to better help our students get through the learning process by thinking about what the product is instead of focusing solely on the process. Um, the backward design can be summarized as a process or model for designing instructional materials where the instructor or the instructional designer focuses on the desired end results of a class or course instruction. So basically what we're trying to do is make sure that we know what is, the end goal is for our students. What do we want them to be able to create, or what skills do we want them to be able to show? So in stage one of the clear goals is to identify the desired outcomes. And I'll go into detail in explaining the stages in a few minutes. Stage two, we want to be able to identify acceptable evidence. In stage three, we want to plan learning experiences and instruction. Now, before I start, I just want to tell you a little story of when I first started and teaching. And I don't know if some of you guys have the same story, but I remember walking into my building, just being, hired and things like that. And my principal told me that um, you you want to start planning for the year, and it starts with the first 6 weeks, and then you plan for the second 6 weeks, and then third. And here's your book of standards and TEKS, and just go through it and watch the scope and sequence, and all of these things just ran into my mind, and I was completely lost that first day, and it completely um, changed my mind on what teaching was. I was ready to back out of the whole profession, but just because I didn't understand how to plan. So the backward design for new teachers is good. It's a good tool, that a good theory that you can use, because we know the end result, we know the goal, we know what we want our students to accomplish, and all we have to do is build on what we know we want them to be able to do. So let's go into the process. The alignment, pretty much, of course, it's a backward plan. So in stage one, what you want to do is know or understand uh, what we want our students to learn in your classroom. So not only do we have to know what we want our students to learn, but they should know what they have to learn. The backward plan doesn't just work for teachers, it could work for the student. If the student is given um, the information on what he is creating, what is his final goal, I think that student is better suited to do well in your class, because we don't have to hide information from our students. We can let our students know what it is they are creating. So stage one, know what we want students to learn in your classroom. Stage two, we prepare assessments, both formative and summative, that allow us to collect evidence or data to measure student learning. In stage three, that's where we build our activities. So our job right here is to provide students with learning strategies, proving practices, or proper steps that take them through a learning process. So what we're going to do is pretty much unpack a math expectation or learning objective, or TEK. And the one that we've decided to pick was six TEKS math level 6, 6.3, number and operation. And what's going to happen here is the student's going to learn to apply mathematical process standards to represent addition, subtraction, multiplication, and division while solving problems and justifying solutions. Remember, what we're trying to do here, um, It's always going to be the product, over the process. So the purpose behind the focus to make sure that we clearly align specific learning goals, skills, and expectation to meet our student needs with those learning objectives. So basically, we don't want to force feed our students a bunch of activities or busy work and see what they can do at the end. It's better to come in prepared with a plan. So what do we want our students to be able to do? They should be able to recognize that dividing by a rational number and multiplying by its reciprocal results in equivalent values. Determine with and without computation whether a quantity is increased or decreased when multiplied by a fraction including values greater than or less than 1. Represent the integer operations with concrete models and connect the actions with the models to standardized algorithms. Add, subtract, multiply, and divide integers fluently. And multiply and divide positive rational numbers fluently. So throughout the year, what you're going to use is a template that pretty much allows you to build or unpack the standard and go through the assessment evidence and what the learning activities will be. So you have all three stages laid out for you, and you'll have copies of this all throughout the year. We'll make sure that this is available for you to use. If you have any questions about any of the sections, remember we are backwards planning. So we're always going to start with stage 1, go through stage 2, and understand what comes later are the activities that they will go through as practices. So in stage 1, learning with the end in mind, the goal is to establish the goal. So students have to know that we're dealing with number and operations. The student applies mathematical process standards and represents addition, subtraction, multiplication, and division while solving problems and justifying solutions. So what I love to do, and I always tend to do when I was teaching, basically, was I go through the essential question as I unpack. So what are the questions that students can keep in mind? How can integers be modeled? How do the models of integer operations relate to the rules for integers? Why is a negative times a negative a positive? So those are the essential questions that students have to keep in mind while working through this whole goal, this learning goal. Things that students will learn to understand. Addition and subtraction of integers can be represented through various models. Multiplication and division of integers can be represented through various models. Also, operations with integers can be used to solve applied problems. Students will know the rules for completing the 4 operations with integers, basically how to add, subtract, multiply, and divide. They then will apply this understanding to solve problems with a context to solidify their understanding of integer operations. Students will also be able to apply these rules when adding, subtracting, multiplying, and dividing in order to solve problems. Now that's stage 1. Pretty much this is the goal. This is what we want our students to be able to do. The proof, stage 2. So here's the assessment evidence, basically the performance task. So this is pretty much a project-based assignment. So at the end of the unit, the student will pretty much understand integers. And what we have for him is a concept unit, which is integers. The other evidence of their learning or how to assess them is going through formative assessments, where students will be taking assessments as the 10 questions. There are 3 of them: rational number operation, adding, subtracting integers, multiplying and dividing integers. And the mastery assessment score is 8 out of 10. Practice, not a final, practice. Stage 3, the learning plan. So basically here we're going through learning activities, uh, and we have 3 learning activities that have also built-in resources that can be used by students if needed to, I guess, check for understanding, or they want a supplemental aid that, not a supplemental aid, but something that will, help them go through the learning these activities a little bit better. So here we have learning activity number 1. So it pretty much is addition and subtraction of integers, and can be represented with real world context through various models. And you can see the resources are built in where they have an integer game, and it gives you the purpose to solidify an idea by subtracting a number is equivalent to adding its opposite. Here we have resource doesn't matter. And the purpose, if you see that, if you can read that, notice that reversing the order of the two numbers in a subtraction problem results in the same magnitude with opposite signs. Uh, Activity number 2, multiplication and division of integers can be represented with real world context through various models. And you have 2 resources there, or sorry, 3. And in number 3, our third activity, we have operation with integers can be used to solve applied problems. And the resource that we're going to use are star level questions. Um, so as you can see, we just went through the process where we backward plan a mathtique. And in the end, we now have our activity. We started with our goal and we have our end activities.